Hi, everyone.
Hello, can the attendees, can you guys hear us? Can you guys see us?
So they can't unmute because we're in webinar.
Yeah, so only the chat.
Okay. So
yeah, but they can use the chat, exactly.
Awesome. Thank you guys. Welcome. We're gonna wait another minute or two, allow people to hopefully show up, and then we'll get started.
It's good to see our friends from the statistics department. We do not get to see you as often that I would like to. Hi, Ben. Hi, G. How are you doing?
Good, how are you? Thank you for inviting us to attend this.
No. Our pleasure. We are very thankful.
We have 22 attendees, Bramar. Do you want to wait another minute or two?
I think we can get started.
Get started.
Mm-hmm.
All right. All right. Well, thank you everyone for joining us. Good afternoon. So let me introduce myself. My name is Matt Zawistowski. I'm a clinical assistant professor in the Department of Biostatistics and also the associate director for the Big Data Summer Institute. And so that's sort of what brings us all together here is the Big Data Summer Institute. So a little background on why we're even having this event today. So today would have actually been the last day of BDSI that you all applied to. And so traditionally on that last day of BDSI, we have a professional development day. And, so after 6 weeks of being brainwashed into believing that data science is the one and only path to take, we spend one day telling you how to achieve all your goals in data science. And so we do that through a professional development day. And so what we usually do is we have speakers from the departments of biostatistics and statistics talk about their departments, and especially from the undergrad perspective, the thing people are often most interested in is hearing a little bit about the application process. And so we think that's been very helpful based on feedback from previous students. And so even though COVID canceled BDSI, your plans and your goals carry on. And so we thought that it was important to still have this professional development day for all the students that apply to BDSI. So just to give you a little itinerary of what we're going to do today, what our agenda is. So we'll hear from Dr. Bramar Mukherjee, who's the founder of BDSI. And then we'll have Biostat and the Stat Department each give separate presentations about their departments and also the admissions committee. Thank you to everyone for the pre-submitted questions that you submitted. So I've shared those with faculty members and graduate student representatives from those departments. They're going to do their best to answer some of those pre-submitted questions in addition to their prepared remarks. And then we will have a live or after graduate students talk, we'll have a live Q&A session where we'll respond to any questions that haven't been answered during the event. So just quickly, just wanted to let you know who we are on this call. So as I said, Dr. Bramar Mukherjee is the founder of BDSI. I think this would have been year 6, I believe, for
yes.
BDSI.
Mm-hmm.
Also the chair of the Biostatistics department. So Jian Kang, myself, and Sebastian Zollner also work on coordinating BDSI. We have Tara Smith, who many of you probably emailed with during the application process, and Davina Barron, also included in the BDSI committee. So as I said, one of the great parts about this is the opportunity to hear directly from faculty, from the departments you might be interested in applying to for graduate school. So we have representing Biostatistics, Dr. Michael Banke and Nicole Fennick. And then from the Department of Statistics, we have Drs. Jizu, Ben Hansen, and Long Win. But as you all know, I mean, to get the real truth, you have to go to the graduate students to hear about what their experience is like. And so we're very fortunate that we have numerous students joining us. So from the Department of Biostatistics here at University of Michigan, we have Jonathan Boss and Abhay Haku. We have Corey Sept, who is a incoming student to Harvard's Biostatistics department. All three of these students are BDSI alums. From the Department of Statistics, we have Dan Kessler, Charlotte Mann, Zoe Renberg, Ed Wu, and Natasha Stewart. And so you'll be hearing from them a little bit later and have the opportunity to ask them questions. All right, so that's a little bit about us. So we just wanted to take a minute to learn a little bit about you. We had so many applications for BDSI, and so we were curious who is joining us. And so Tara just put up a link in the chat for a poll everywhere. And so if you have access, can you try to click on that link? And we're just going to try to collect a little bit of information just to see who's out there. So the first question is, and this is, you know, one of the realities of this Zoom environment, where is everybody joining us from today? So one of the cool parts about BDSI is that we really do have worldwide representation. In the previous years, we've had BDSI participants come from India, China, and Mexico. And while this time frame might not be totally amenable to this, oh, there's somebody from India joining us, fantastic. So we have people joining us from all over the world, which is great. And that's one of the things we really try to achieve in BDSI and data science in general. So curious, what schools are people currently attending? So we make a big effort to have students from a wide range of universities, both large schools, and there we have Purdue and Smith College. So right on the different ends of the spectrum right there. And so that's one of the things we really like to see is representation from different types of schools. Awesome. So you can see how wide the range of schools for people that were applying to BDSI, but then also have interest in data science and big data are. University of Belgrade, cool. All right, so last question here. Obviously, the pandemic, Ohio State, so obviously the pandemic has been, you know, a source of cancellations for lots of different things, be it, you know, BDSI or, you know, we've all had probably summer plans canceled, but we were sort of curious, you know, maybe you found something that wasn't so bad, some kind of positive experience you've had during the pandemic. So just curious if you can respond, you know, something that's been, you know, something that was a positive thing that might not have happened. So cooking more. Learned to ride a bike, very cool. This is mine. I done way more fishing this summer than I've normally done. Like a lot of people saying, spending time with family. Learn a new language. I know my daughter is learning French right now, all through an app online. So very cool. So hopefully there have been some positive things that have come from the pandemic, that at least we can find time. I think that's the common theme here, is finding time to do things that maybe wouldn't otherwise have done. All right, so very cool. Nice to have this big audience of people that are watching. You could see you're coming from all over the country, all over the world, all kinds of different universities, all with this common interest in big data. So with that, I will hand it over to Dr. Brahmar Mukherjee to give her welcome and overview.
Matt, I need permission to share screen.
Yep, okay. You should have it now.
I have it now. Thank you so much. So thank you everyone for joining us. And I was just, as you can see, I was working on my slides till the last minute because I was not sure what Matt is going to say. But I am very happy. And, you know, the pandemic has led to a lot of cancellations, right? So, and I have to be honest, I'm not unhappy about all of them. But this particular cancellation of BDSI being canceled this year has been really a blow to my heart, because this is such an integral part. It has become such an integral part of my own academic existence. I feel like I draw a lot of my sustenance for the rest of the year through this 6 weeks, and by interacting with young minds who are thinking about data science as a vocation. So there is nothing more like gratifying and inspiring at the same time than this experience. So I'm still very happy to be able to meet you virtually and say hi to you. And I just want to do a little bit of overview of the program and what led us to develop the program in this way. And then, you know, I'm not going to talk necessarily about biostatistics and statistics graduate program, because that's what this is mostly about, but Matt gave me some time to talk about BDSI, and hopefully many of you will be able to participate next year in BDSI. So when we started thinking about BDSI 5 years ago, the main kernel at the time, big data, data science, was still a very new phase and how to teach people, and now we have learned more. But 5 years ago, 2015, we are still figuring out how to introduce it to undergraduates. So that sort of led to this program. And the pilot program, initial one, was for 4 weeks, and the next 4 years. So we have had 5 years of the program, and this would have been the 6th year. So we have run the program for 6 weeks. So big data, if we talk about big data and health data science, we first need to talk about how do we define big data. So I think that each of us, there are 44 of us, we can come up with 44, if not more, definitions. But we wanted to define it as data sets with large number of records and large number of variables potentially. That could, large number of records could mean like the electronic health record data, where you have millions of patients in Michigan medicine with thousands and zillions of predictors, including the disease codes that they are getting, the lab results, and so on. But the characteristics of big data is not just through its dimension, it's through the nature of collection of data. And that's something that we often forget, how the data were collected. So it's messy, heterogeneous, collected from different sampling mechanisms, just cobbled together for analysis. Our classical intuitions, mathematical intuitions that we learn often fail, and visualization tools for big data are quite different. And so big data has become a buzzword, and you know, so there are, we started with the 3 V's of big data, and then it became, and I'm going to show you those 3 V's in the next slide, but then people went overboard, and this is the last article I found, which in 2017 talks about the 42 V's of big data. But initially, the 3 V's, the kernel V's, were the volume, variety, and velocity of data coming at, like, real life streaming data and data from wearable devices. So these are examples of data sets which are coming at you at a huge speed, and you have to decide what part of it to use for meaningful statistical inference. So the goal of this program is to not just talk about the size of the data, but also principled inference. How do you go from big data to knowledge? And that in general, I think, is a core principle of all the data science departments in Michigan, that when you assemble data, when you get a data set, how do you get from the data to actionable knowledge? And sometimes knowledge, and in School of Public Health, particularly actionable knowledge. So in my definition of data, I put it as a weighted combination of statistics and computer science. And the problem is that and I know that many of you are computer science majors, some of you are statistics, biostatistics majors, and I left mathematics out. So that's a huge sin that I committed, but mathematics is actually really at the background of both statistics and computer science tools that you learn here. And so it's problematic because the weight sometimes goes to 0 in some world and goes to 1 in some others. So the goal of this program is actually to strike a balance between these two domains. And so as you can see that so basically we said that and this is a graph, that this is how many people are actually searching for data science and statistics and computer science. And this is a Google trend. So we know that the Google trend data is very faulty, but still let us look at that. And so this is historically starting from 2004, and you cannot see just the very bottom of my slide. So the blue, so when people are searching for jobs, how many people are still searching for data scientists, statistician, and computer scientists? So you see historically, people have started looking at data science jobs from 2014 onwards, right at the time when we started this program. It is, and you can see that the yellow line is the search for a computer scientist, and the blue line is for a statistician. And they are, there is clearly, even with the biases and all that, there is clearly an increasing trend for data science to data sciencey programs and the job title of data scientist. And you can say that this job title did not exist before, but it is still, reassuring to see that the blue line lies above the yellow line. And with that, no offense to computer scientists, but with that, actually, a lot of new journals have started. So for example, this is a journal, Harvard Data Science Review, and we have been really kind of bold in that space. And the tagline for this journal is a telescopic, microscopic, and kaleidoscopic view of data science. So we are using words for data science that we hesitated to use for statistics. And that's sort of taking us into a bold frontier. Many of you have watched the movie Imitation Game, and you can see that the dynamics of the movie is that a team of scientists working, actually this is very relevant right now because this type of wartime science is going on during the pandemic, group of people working together day and night to solve a problem which is facing a crisis for humanity. And Alan Turing and Benedict Cumberbatch, is stealing the show, building the machine, and the only statistician on the team, Jack Good, is sort of lying in the behind doing optimal calculation for likelihood so that the Germans do not figure out that they have actually cracked the code. And he has a very minor role, and that has to do with something of a popular image of a statistician. So the goal of this program has been to really integrate different tools, but also really focus on solving major problems. So instead of competing with computer science or competing with mathematics or thinking about where do the weights go, those data adaptive weights in statistics and computer science, can we bring people together? Can we bring, for example, causal inference, and these are some texts that I have really enjoyed learning, some tools about algorithmic modeling, artificial intelligence, probability, all of them together into a whole ensemble so that we train the generation of data science students better to solve impactful, influential problems. And the 3 C's of a modern statistician: computation, collaboration, and communication. These 3's are very, very critical for our program. I just wanted to show you some statistics in terms of the 5 years of program. As I said, that we have grown incredibly. In the last 5 years, we have taught 203 students. Our admissions rate, it's a quite selective program, is about like 15 to 20%. Acceptance rate, on the other hand, is very high. So we have created a reputation for ourselves, and we have a strong representation. It's our best effort to have a diverse cohort and also have trainees from the underrepresented minorities and also people with non-traditional backgrounds underrepresented in statistics. So we really focus on a T-shaped learning, where in the morning time you hear a bunch of lectures from statistics, biostatistics, and computer science. And this is a program which is really is a joint program run by these three departments. So in our campus, we have a lot of collaboration among the data science disciplines, but this is a program where three departments have really come together, and there are Jenna Weens and Johan from statistics are very involved in the program. They lead one of the projects, and then we have a medicine component of it. And because our funding is actually we are one of the SIBS programs, and so comes from the National Heart, Lung, and Blood Institute. We have a lot of focus on cardiovascular health, and we also have projects in cancer and type 2 diabetes. So this is to give you a sense of the field, a test of the problems people are working on. And also, you basically see a lot of, like, this is the horizontal part. So this is the breadth of the T, where you get exposed to different tools and techniques that people are working on. And then in the afternoon, you actually do the vertical part, or the in-depth study, in 3 project areas. For example, last year it was genomics, machine learning, and data mining, and we rotate these project areas. So for example, we have had projects in electronic health records, we have projects in brain imaging, so we rotate those group projects. So in the morning, all the cohort, 34 to 40 students, are together. In the afternoon, they divide up into 10 students and then talk about and work on hands-on projects. That's the best part of the program, that you actually deep dive into one area and learn how to actually model. So you are thrown with like very big, complex, messy data and ask scientific questions. And by the end of the 6 weeks, you present your answer to the scientific questions and any methods that you developed along the way. And the fun part is also coming together. And so we have great food. And so in a sense that we don't have the program this year, which is actually, people live in a dorm. That's why when we thought about the SIBS programs in the country, whether we should continue it virtually or not, we were thinking about this because it is very difficult to simulate the environment that you have when you live in dorms, and the BDSI alums can speak more to that. The bonding that you develop through social events. You can see the kids went to the Michigan Big House. We have a very nice conversations around like women in statistics. We go to the art museum. So this is a fun 6 weeks. The Ann Arbor is very beautiful in the summer, and it's actually beautiful all year around. And then you have Top of the Park, which is our summer festival. So this is a very special experience. And continuing that, for PDSI students who are looking for more data science education in our master's program, we have the health data science concentration, which was launched from last year, which is a series, an ensemble of data science courses in, for example, R's interface with big data, machine learning, and also sampling, design, case studies in big data, which is sort of modeled upon BDSI in terms of immersion into data science areas with focus. So that's a concentration in our master's degree, and a continuation to PhD possible. And so I just want to end that, if you're thinking about graduate programs, I hope that many of you will consider coming to BDSI next year, and I'll look at the chat questions as well that you have about BDSI. Happy to answer anything. But I want to, the pandemic has really pushed us. Data scientists are probably more important than ever. So this morning in a journal article, I was defined as a data warrior, and I have been always a data dreamer, a data scientist, but data warrior. It really feels like actually fight and really trying to put our data science skills together to fight against this virus. And so if you wanted to look at some of the biostatistics research, our faculty and students have really taken up this challenge in contributing to COVID research. I want to share, one of our students, Holly Hartman, developed an app so that the cancer patients who are delaying their care because of the COVID pandemic, how can they optimize their care? And that app was featured in the Washington Post last week. So people are really pursuing very high impact work here. So with that, I think I am already over time. And so I just want to wish you all the best. I'm really missing BDSI, but I hope that I have a chance to interact with many of you in reality, in person, as well as virtually. And this is the, John Lennon Circle in Strawberry Fields Park for Strawberry Field in Central Park. And you see the little yellow submarine that's there. And we all have our little submarines with which we traverse the world. And for data scientists, for us, it has been data science, mathematics, and statistics. That's what we love, and that's how we navigate the world. And this is a strange time, unprecedented time. I wish all of your loved ones are stay safe, staying well, staying determined, staying persistent, vigilant, resilient as we come through this, as science makes its advances and to rescue us from this difficult time that society is facing. And I want to reiterate that data science is so important in this current time. So with that, I think I'll hand it over back to Matt.
Thanks, Bramar. So next, we will head to Mike and Nicole.
Are you seeing my screen?
We are.
Wonderful. Well, thanks, Matt. Thanks, Bramar. It's truly a pleasure to be here. It's more pleasure, honestly, when we're in person at BDSI. I've enjoyed it each year of the program. I haven't had the deep involvement that Bramar and Matt have, but it's been a pleasure each year meeting with BDSI students and talking with them. So a pleasure to meet you all today. And it's my task to talk about the admissions process in biostatistics. Why don't I just go ahead? And so biostatisticians develop and apply statistical designs, analysis methods for biomedical research to turn data into knowledge. Statistics, as those of you who have participated in BDSI know, and those of you who are interested might well know, is really an exciting field in which to use your knowledge of mathematics, your interest in mathematics, and to be able to apply it in areas of science. Our program, I think it'd be fair to say, is one of the best in the world. We have both master's and doctoral degrees combining theory and methods and computing and application. All of our PhD students and many of our master students are funded in the sense of being paid tuition, stipend, and health insurance. And one of the great things about the field of biostatistics is there are really good, really interesting, well-paid jobs. I like to tell people, please don't tell me you want to do biostatistics just because, well, sorry, let me put that a different way. I tell people I don't try to convince people to do biostatistics just because there are jobs, but you've come to us today to say maybe you are interested in that field, and so the good news is there really are jobs. We've had a sizable program for a number of years. We have about 200 students, about 40 faculty. We're approaching now 2,000 alumni and about $40 million of research funds. We are part of the larger School of Public Health here at the University of Michigan. Our biostatistics department is joined by environmental health sciences, epidemiology, health behavior, health education, health management policy, and human nutrition. So we're in an environment where we are surrounded by exciting work going on that's always important and is particularly important now in the days of the pandemic. In terms of the admissions requirement for our program, our admissions process is based on math background in terms of the courses taken, GPA, general GRE. We don't require the math GRE, but we do ask for the general GRE, letters, statements of purpose. For the master's program, we ask people that have had multivariable calculus, linear algebra, and introductory statistics, We're delighted if people also have advanced calculus, other math and statistics, computer science. For the PhD program, in addition to a master's degree, we ask for a degree in advanced calculus or real analysis, depending on your point of view. One of the set of questions that came up in the questions you posed in advance of this meeting was what advice can we give about applications? And so here are my bits of advice. I'd love to hear what other people think about this, but for me, when I'm reading the sort of 500 applications that we see each year in biostatistics, I'm looking to see someone make clear why they want to do biostatistics, and if they do, why they want specifically to do our program. I like to see people describing their background, their goals now, and their goals in the future. If they have chosen already a faculty member or a possible area of interest you want to pursue, that's great to include, but honestly, most people haven't at the time they're applying. But it's great to include if you have. It's no problem if you don't. Writing clearly and well is really important. Some people think, well, this is math, right? So writing doesn't matter so much. Well, no, writing matters a lot. And so doing a good job, making your statements, writing clearly and well does matter. In terms of your letters of recommendation, choose letter writers who know you well, who can say something about you. Saying, you know, she got an A+ in my class, well, that's nice, but that we can learn from the transcript. And so having someone who you've interacted with, who can comment on your relevant skills, your personality for that matter, relevant skills like math and statistics and computing, any research experience you might have had, all those things are valuable. Something to decide, and this is not clear cut, but sometimes we have blemishes. For example, maybe in my first year, I didn't do so well in courses because there were things going on that I was adapting to, or maybe there was a death in the family my third year of school, and things were tough then, and I didn't do as well. You certainly are not required to do that. It's totally up to you, but that's something worth considering. And then there was one question that I particularly liked. What are the most important parts of the application? Well, all of them. So you really want to focus on every bit, because we in biostatistics, we do a very holistic admissions process where we look at every piece of information that I've just described, and anything else that you happen to put in. Just to give us, oh gosh, I've got a phone. Okay, my wife picked it up, great. Phone in the background, that's one of the challenges of working from home. We had about 550 applications last year. Similar numbers, masters and PhD, a few more masters. I can't add up, those two numbers don't add up. Part of it is because some people applied to 2 programs, and other people who applied to the PhD were actually admitted to the masters. But the important number here, I think, is we had about 550 applicants. We have 74 new students coming or being involved in the program, whether they're coming to Ann Arbor or doing it from a distance. All the PhD students, as always, are fully funded in the sense of tuition and stipend and insurance. About 40% of the master students are funded, about half of them fully funded. One of the things I like about our Department of Biostatistics is we have students from a wide range of backgrounds. For example, for this incoming class, we expect to have about, 29 students from mathematics or statistics or applied math or things of that sort. We have about 15 we're expecting from the biological or social sciences, and then we have 6 people who are from other disciplines for that total of 50 master's applicants. For our PhD program, most of our PhD students actually come from our master's program. We do take students from the outside, we absolutely do, and we really welcome people with a master's from outside. But most of our admitted students to the PhD come from our program, because honestly, we look at them first, we give them preference because we know them. There are lots and lots of cool areas in biostatistics. I've listed a few. Bramar's already been talking about big data and computationally intensive methods. A strength for the department is statistical genetics and genomics and bioinformatics, biomedical imaging, survival data, survey methods, missing data, clinical trials, Bayesian methods. There's a long list, and this is only a subset of what we do. As Bramar mentioned, we've developed rapidly a much stronger emphasis on infectious diseases. And this just gives a little bit longer list than she did of some of the current projects going on in the department focused on COVID, and obviously all starting quite recently. but all of them very active and making meaningful contributions to the field. I've got at the bottom the URL for the website that Bramar mentioned previously that gives a listing of these different projects. In terms of the programs themselves, for the master's programs, they are 48-hour programs over 4 semesters, and so it's roughly 20 months. 36 credit hours in biostatistics, 3 in epidemiology, 1 somewhere else in public health, and then the remainder being optional courses. For the MPH, the Master of Public Health, one of our 2 degrees, we have the Master of Science that almost all of our students do. We also have the Master of Public Health administered through the School of Public Health, and that also requires an internship. With a master's degree in biostatistics, one is prepared to go out and do good work. And I think particularly from our program, well prepared to go out and do good work, typically as a team member, being part of a team, maybe a scientific team, maybe a statistical team, maybe a big data team, and play a part in that. The master's coursework, as I mentioned before, combines theory and methods. We have a first-year sequence on probability theory and inference. We have a 3-term sequence on basic statistical methods. We have a capstone course, Biostatistics 699, which is what everybody calls it, but it's actually called Analysis of Biostatistical Investigations. That is sort of our better version of a statistical consulting course, in which students come in. The instructors, typically 3 at this point, will say, okay, here's a study I want to do, help me design it. Now we've got the data for the study, go out and do a statistically rigorous analysis, write up a thoughtful report that I as a non-statistician could understand, and then present it in a way that I as a non-statistician could understand. In that course, you will be quite busy, but you'll learn a lot. And when I talk to our alums, which I do a lot, this is the course that always comes up. It's a really valuable course, an important component, not just for our master's program, but it's also required for our PhD program. Okay. Bramar mentioned the health data science program, and since we're running a little behind time, I think I'm going to skip those couple of slides because she did already describe them. And I'll move next to our PhD program. The PhD program typically requires 3 to 4 years after the master's, so 5 to 6 years after the bachelor's degree. Typically, students do 1 more year of coursework. If they haven't already had real analysis, they do that. They'll take a 2nd year of statistical inference, a course in stochastic processes, and some electives. There's a qualifying exam, and of course, a dissertation. One of the big attractions from my perspective of a PhD is once you're done with that, prepared to become more of a leader, to take on a leadership role wherever you might go. Doesn't say you have to do that, doesn't say everybody does, but that is an alternative, and it gives you experience and self-confidence that you can go out and do original research. We support, as I mentioned, a large number of our students, and I am not being able to see the numbers. Let me block, okay. And I still can't see the top numbers, so I move that, okay, great. So as you can see, the large majority of our funded students are funded as graduate student research assistants. This is the opportunity to be really an apprentice, working with a faculty member in the department, possibly, in fact, likely, faculty member or members from other departments with subject matter discipline knowledge. And so the large fraction of our students are supported as GSRAs. We have 19 slots roughly, and that varies between semesters, but about that of students as graduate student instructors. For us, that's really being a teaching assistant, where you'll help out with a course and get useful teaching skills. And then we have a subset of students, about 18 this year, that are funded as fellows under our genome science training program or our cancer biostatistics training program, or from one or another of the different fellowship opportunities through the University of Michigan. Oops, why is it not wanting to move? There we go. And a really, let me just double check that I didn't lose anything. There we go. A really nice feature of our program that is sort of in addition, but a valuable complement to what students do in class and also do in their research or teaching, is a program called Statistics in the Community. StatCom is a community outreach organization that provides, that sort of is led by graduate students with faculty advisors. Graduate students come from biostatistics, statistics, and the program for survey methodology at the U of M. And it offers the expertise of the graduate students free of charge to nonprofit, governmental, community organizations in areas of data organization, analysis, and interpretation. So this means that there is another opportunity besides what you might be doing in your classes or in your research assistant position to be involved, to do research, and to do it in a way that's very valuable to others. Okay, again, I'm getting things blocked here, so let me move things around. Job opportunities in the field of biostatistics, as I said before, are great. Graduates of our program have the advantage of the department reputation, the importance of the field, the strength of the students to find great jobs both in the US and worldwide. Positions in universities and research centers exist, and certainly lots in government and in industry, with pharma and biotech being particular foci for our graduates to go to, although they go to many other places besides. The departments post notices of available opportunities and host recruiters to come visit to talk to our students. So one of the set of questions very logically came up was, what's happening now in the days of COVID? So for this year, or at least for this semester, most of our classes and meetings will be virtual. Many of our students may not be able to travel to Ann Arbor because of travel or visa restrictions. Some others may choose not to come to Ann Arbor as well. We're going to be dealing with that well. Our faculty are working hard to prepare for teaching virtually. We had some experience with that the last couple of months of the last semester, and people have now happily had a lot more time to prepare for that rather than twisting on a dime and going from fully in person to fully virtual in a period of less than a week. In terms of what that might mean in terms of applications, well, usually a weaker economy results in more graduate student applications for that year. I can't predict what's going to happen like this coming year because this is a year like no other from my perspective. One change that our department is making in the admissions process, or at least is likely to, is to make the GREs optional or perhaps not even used. I'm not sure which it'll be, but probably one of those two for this next admissions year. We'll be deciding that quite soon. We will certainly be having more, I think, admissions events, and certainly many more of them virtual events. And while it's fair to say the job market, I think, is tighter now, it makes it a particularly good time to be picking a field where there are lots of jobs available. And I can say anecdotally that the students of mine who have been graduating recently have in fact had good fortune in finding good jobs. Okay, timeline. We're actually going to have, not on here, but we'll actually have our Prospective Student Day that we have each fall. It's likely to be in October. Date is not yet set. Normally we would have set it a while ago, but COVID is making planning a bit more complicated. Applications deadline will be December 1st, admissions decisions and funding decisions in February. Decision deadline for you all, if you're accepted, will be April 15th, by which you must decide where you're to come. April 17th is when we will ask people to fill out a form describing the people you'd like to work with, the areas you'd like to work with, and then we match students to positions amongst the funded students. New student orientation will be late August. In interest of time, I'm not going to go over this point by point, but this was a statement made by our dean early in COVID times, talking about what we in public health value. And I think I found it very moving. In fact, the first time I tried to read it, I cried. So maybe I'll not read it. But fundamentally, in biostatistics, in public health, we believe in compassion, innovation, inclusion, and pursuing impact. And doing all of those things is particularly important. It's always important, but particularly important in these complicated times. If you might be interested in graduate studies in biostatistics, we have two wonderful student services persons. Nicole Fennick is with me, with us on this event today. Fatma Najari is the other. I'm always happy to talk to students about our graduate program, graduate study more generally. I've actually been chair of our admissions committee all but 2 or 3 years since we had an admissions committee starting in the 80s. It's something I love, I believe in, and I enjoy. So do feel free to reach out if you have questions. And I think that's it for me. Thank you very much.
Hi, Mike. We had one question come in while you were speaking, if I could ask.
Please.
So Madeline asked, would you say the Biostat PhD program is more applied or theoretical?
So that's always in the eye of the beholder, right? It's like my father-in-law used to say, it depends on where you sit, how far your feet hang down. So we think of it as a useful mix. We really believe in the importance of statistical theory and methods. We also believe in the importance of application to real science, real data. And so yeah, I'd be hard pressed to say whether it's one or the other, because honestly, it's both. Both are really important to us.
And her other question was, I think you mentioned this a little bit, but funding opportunities for the master's program.
Yeah, so we have, and if we'd been talking 10 years ago, I'm sorry to say, everybody essentially was funded. The program has continued to become more popular, more applicants, and the number of funded slots has gone up, but not quite as quickly as the number of applicants. And so right now, we have about 35% of our current students in the master's program funded. For this next year, it's going to be 40%, but this time next year, we're going to have some of those who are funded just with partial tuition. So of the fully funded master students for whom we pay all the tuition, their stipend, and health insurance, it's closer to 20% for this coming year. That said, for people who are strong students, we are eager to provide funding, and we do that.
So we had, is funding for the master's program also available to non-US citizens and non-permanent residents?
Yes. So of all those sources of funding I listed for you, the graduate student research assistants, which my memory's bad, but it was about 95 slots, the graduate student instructors, about 18 slots, 19 slots. All of those are available to anybody from anywhere. The slots that are not available to everybody are some of the fellowship slots, and that total number was, I think, 18, if I remember correctly. About half of those are available to international students, about half are not. So put in total perspective then, of the 100 plus, the 120 plus, almost 140 students we're supporting, only about 10 of those slots are not available to international students, which means that we move people around to make sure that the funding that we would like to provide them, we can provide them. And we do that, and we've done that for many years. It's important to us because we deeply believe in having a broad range of people from all walks of life all around the world.
Okay, and we have one last question for Mike, and then there'll be more time for questions later to the participants. Kanari asks, are PhD students funded through the department or by individual faculty members?
Really good question. The answer is both, actually. There is a commitment to students from the department. And so when you get your admission, if we admit you to the PhD program or if we admit you as a funded master's student, the initial commitment to you will be from the Department of Biostatistics. Once you have decided to accept, once you tell us with whom you'd like to work and the faculty member then chooses with whom she or he would like to work, then the commitment is from the faculty member. You still, however, have the commitment from the department. So if you and that faculty member, for whatever reason, don't get along, that's actually pretty rare. If the faculty member's funding happens to end, which does happen sometimes, you still have the commitment from the department and you still will be supported. You might then end up working with a different faculty member.
Great, thank you, Mike.
Pleasure. Thank you all for taking the time to come today. Look forward to more conversation later.
All right. So our next panel of speakers are going to be from the Department of Statistics. So I will welcome Doctors Ben Hansen, Long Wen, and Ji Zhu. And I don't know which order you guys are going to speak in, but I will let you just take control of the screen.
Oh, so Matt, I will be the first speaker.
Okay.
So let me just share my screen.
Got it. There we go.
Okay, good. So hi, everyone. I'm Ji Zhu. I'm the Associate Chair and the PhD Program Director of the Department of Statistics. We also have two of my colleagues, Professor Long Wan and Professor Ben Hansen, and some of our PhD students and the master students here today. So Long is the director of the master's programs, and Ben is the director of the bridge program. And we will each give presentations on our respective programs. And then together we will answer the pre-submitted questions. So why you should consider the statistics program at Michigan? Our department has one of the top graduate programs in statistics in the country. According to the most recent US News ranking, it's tied for number 7 among statistics, among all statistics programs. You know, this is a point estimate, and as a statistician, we all know that there is an uncertainty with every point estimate. The NRC ranking gave us a confidence interval. And according to the most recent NRC ranking, our ranking is between number 4 and the number 12, where the midpoint is number 8. So it's consistent with the US News ranking. And also, as Burma has mentioned, Ann Arbor is also a pleasant place to live, and it is consistently ranked as one of the best places to live in America. This picture in the middle, that's West Hall, that's where the statistics department is located. As for the people in the department, we have 24 full-time regular faculty in our department, originating from all over the world. And our graduate students also come from many different countries and regions. Overall, we have a very open, friendly, and culturally diverse department. So as for the PhD program in statistics, our goal is to prepare our PhD students for research career. And the key feature of our PhD program is its flexibility in terms of research directions. What our PhD students do for their thesis range from interdisciplinary research, statistical methodology, to theoretical statistics and the probability theory. And the PhD program, sort of roughly speaking, can be divided into several milestones. The first year is mainly on coursework, and most students will start doing research in the summer after the first year. And the second year is a transition year from taking courses to doing research. And the second stage is to write a research proposal and give a presentation on your research proposal to your thesis committee and then become a PhD candidate. And this usually happens during the second or third year. And the last stage is to work on your research projects, write a thesis, and then defend your thesis. Okay. And I will skip the detailed requirements for each stage. And if you have questions, I'm happy to answer them later. So in terms of funding, our PhD students are guaranteed for funding for 5 years, and this includes a tuition waiver, stipend, and also health insurance. And also, like in recent years, we have been able to fund our PhD students in the summer, given that they engage in research with their thesis advisors. And also most of our first and the second year PhD students are funded by so-called graduate student instructor appointments, what we call as GSI at Michigan. And many of our more senior students, such as students in 4th or 5th years, they are funded as a graduate student research assistant as GSRA. So in terms of training, we offer a combination of teaching and research. There are also many other funding opportunities for, say, conference travels from both the department, also the Rackham Graduate School. in terms of activities, I just want to mention that we have a very active PhD student council that organizes many activities, both academic and social, including a weekly student seminar series and many other department events, such as the Pi Day, the Stats Giving Day, etc. And in terms of the application deadline is December 15th. Although we still accept the application materials such as letter of recommendations after December 15th, but in order to give you the fair chance now to reduce the opportunity, it's better to have all the application materials sent by this deadline, December 15th. And to apply to the PhD program as a general rule, we look for students who have a good background in calculus, linear algebra, probability, and statistics. And real analysis and good computing skills are also very useful. But when we look at each application, we will look at the application from all angles. And it's often the case that an admitted student is strong in one area, but not so strong in another area. And also our admitted PhD students can take prerequisite courses in their first year to fill the gap. And overall, like on average, we receive about 300 to 350 to 400 applications per year. And we make about 30 to 40 offers. And the size of the enrolled class is about 12 to 15. So that's my presentation, and I'll now pass this to my colleague, Professor Long Wan. He is the director of the master's program, and he will give an overview of the master's program. So Long, I'll stop sharing my screen, and if you can share your screen.
So let me share my screen. So can everybody see my screen?
Yeah.
Okay, good. So hello, everyone. It's a great pleasure to be here. And, my name is Long Nguyen. I'm a director of master programs in applied statistics. So let me just give you a quick, I'd go very quickly because many of the relevant information is already given by my colleagues. But this is a typical statistic we have for the cohort in this coming year. We have about 700 applications. It's a popular program, and each year we expect about a cohort of 70 students. Applications coming from the US and all over the world. And what is interesting about our program is that the students who come in have a wide variety of background in statistics and math, but also in many other disciplines in engineering and sciences. So I know that many of you are here because you perhaps are more interested in PhD program, but perhaps some of you are also interested in master program. And so the question that you might raise, why a master program in statistics, right? Could be that you finishing your bachelor degree soon, and some of you kind of know what you want to do. So you want to do a PhD, for instance, in statistics or some other field. But some of you might not be sure if PhD is right for you. You want to try out something, you want to learn more advanced coursework and try to learn more about, say, statistics. And so this could be a very good option. And actually, same thing for me. I had an undergraduate education in CS, computer science and math, and I wasn't quite sure what I wanted to do. I decided to do a master program, actually in computer science. And somehow I realized a great awakening that, oh, statistics is really what I want to study. And I have been very happy ever since that realization. So this is some of the slides for our student admit. Why Michigan? I think G and Brahma already talked about this, but I think it goes without saying that Michigan has strong programs, top programs, not just in statistics, biostatistics, but almost in any other fields, in computer science, in math, in engineering, in other sciences. And this is very relevant because of the nature of our field. We have a lot of collaboration, a lot of connections with faculties, departments across the campus, and the students who come here, especially master students, also get a chance to engage in some of those collaboration and research activities. one of the, I think the standout feature of our program, master program, is that each master student would be assigned an individual, a faculty advisor. This is 2 years program can go by very quickly, and unlike PhD students who have their research advisor, master students who come in might still try and figure out what they want to do and so on. And having this individual faculty advisor would be very helpful in terms of advising coursework and advices for career planning and so on. The structure of this program basically is course-based. There's no thesis requirement. You have to take about 10 courses and you graduate, right? And in terms of the courses, we have some very popular courses on modern statistical methods, machine learning, statistical computing. These kind of courses are very popular. It allows you to speak the language. Say if you want to go out trying to find internship, get a job with the government or industry. And also, and often, you know, once you learn these courses, you realize many of the kind of exciting applications you see, actually, you can also do that too. We, of course, in addition to these kind of popular courses in computing and machine learning and so on, we offer rigorous foundational course in statistical probabilities. And this is really for me, that's what I love about the field. In addition to courses, many of our students are also able to obtain research opportunities with faculty in statistics, but also in other departments, including biostatistics, but also across campus. So there are 10 courses in the program that you require to take, and out of them there are 5 core courses. And these are basic courses that I mentioned, but there are also 5 elective courses that give you the flexibility. These courses, some of them come from statistics department, but you are also allowed and encouraged to take courses from outside of the department. And many of you take the advantage of interesting courses offered by, say, School of Information, Biostatistics, Computer Science, and so on. Most students finish the program in 4 semesters, but actually quite a few of them are able to finish the program within 3 semesters. I mentioned a bit about research opportunities, and this is something that many of our master students are interested in when they come in, because they're trying to see how statistics being applied to different fields, or whether they actually want to have a more advanced degree in statistics. Some of them are able to establish research connection with the faculty from statistics department, doing research with them. And some of them are able to also work with other faculty in other departments. Some departments have many faculty in other departments also have research projects that require help from statistics students, and many of them are also able to engage in such projects. So in terms of funding, we have a limited availability of funding for master student in terms of GSI, teaching assistant. So some of them are able to obtain this. And for international students in the second year, some of them are also able to obtain GSI-ship. Career placement. So as I said, so the statistics vary from year to year, but many of our master students, after they graduate, get positions in industry, in the government. Some of them continuing on PhD programs. We offer a number of career services. We have a weekly digest for job listing, related events on and off campus for those who are looking for such opportunities. And one of the exciting events of the year is the career fair organized by the department. And this is an event where companies especially from the metro area, that come in and offer internship opportunities, and many students are looking forward to this event. And of course, we have faculty advisors who continue to offer advices and as you trying to navigate your path. We have a variety of workshops for resume building and for ways of looking for positions and so on. That is organized throughout the year. So this is an example of some of the companies that come in to our career fair last year. Okay, so I think that is all I wanted to talk about for the master program, and I'd be happy to take this question maybe after a presentation by Ben Hansen.
Thank you, Long.
Okay, so Ben, let me. Do I need to release? Let me stop sharing. Okay.
I'll take a moment to set up my screen share here as well. There we are. Hopefully now you are seeing a screen labeled Bridge Masters Program Information Session. Good, thank you. Thank you, Mike. So this screen is the first slide of a slide deck that I'm going to be sort of presenting some excerpts from. This slide deck comes from an information session we held in the late fall last year as we were recruiting towards our first inaugural cohort of this bridge program that I'm going to tell you about a little bit. And we're likely to hold another webinar information session like that, at least one more in coming months. So if what I say is of particular interest to you, particularly well fits your profile, and or if you have friends, classmates who fit that description, please ask them to stay tuned. So the Bridge program is a new innovation of the stats department. It's part of a broader program at the university that's been around for a couple years longer. But we were able to, starting this last year, recruit our first cohort to this Bridge Masters program. We'll be looking to recruit some more. It is a part of the universities and the stats department's commitment to diversity. And as you'll see, we're talking about diversity in a couple of different senses. The first of which I should mention is has to do with whether or not this is evaluating whether or not this is a program that would make sense for you to think about. You'll see I'm going to describe a couple different screens and filters that would help to determine your eligibility for the program. But the main two situations where students would be interested in this or directed to this both have to do with having a background that's a little bit different than the backgrounds of other competitive applicants to our PhD program. So one scenario would be that you've applied to the PhD program and you have a strong application, but when we start looking at the rest of the PhD cohort that is being assembled, we see that there's some one specific aspect, perhaps more of the portfolio you're bringing, which isn't quite as solid as that of the other candidates. And we think that maybe it would serve you well to have more time to build up that strength. Another use case, another way students wind up in this program is if they found statistics a bit late in their training, their education, maybe even after they'd completed their degree and were out in the work world. We have students of both of those types who will be joining us for the first cohort this year. So there was, I see a chat that says screen sharing may have frozen. Let's see.
And we're just seeing your, oh, now there you go.
Okay.
We were just seeing your first slide.
Oh, thank you. So no, that was just Ben who had frozen. I was talking to the first slide. So let me, I have a couple of points I want to tell you about the Bridge program. First of all, about the curriculum, I don't need to draw this out because you've now had the opportunity to hear directly from my colleagues who lead the master's and PhD programs, and I can sort of explain the Bridge program curriculum as it relates to those. If you come to the Michigan Stats Department as part of the Bridge program, the first thing you'll be doing is working on your master's degree. And so first and foremost there, you'll be doing similar courses to the courses that other master's students take. In fact, you'll be fulfilling all the requirements that they fulfill. One small exception, small difference is that Bridge programs will here and there as appropriate substitute a PhD level course for master's level courses that the rest of the master's cohort would be taking. Another important difference that is specific to the bridge program, and so I'll mention it, is that all students in this bridge program are expected to work on research with a dedicated faculty member in the summer between their first and second years. Just like with the master's program, everyone gets a program advisor that they'll be paired up with at the very beginning. In the case of the bridge program, that advisor is helping you to select things both for purposes of doing the master's degree and with an eye to doing PhD studies later. I mentioned at the outset that there were some filters, so to speak, that helped to define the audience for the bridge program. And this is sort of the second place in which you see the universities and the stats department's commitment to diversity coming into play. The first several things here, first of all, you have to be very interested in stats and have a strong academic background. The program is for US citizens and permanent residents. And past that, we're looking for students who come from a traditionally underrepresented group. And that could be in terms of a couple of different axes. Rather than reading out loud, I'll let you read and refer you also to our website that has these things as well. So a traditionally underrepresented background, or a sustained commitment to diversity in academic and professional realms, and or you've experienced financial hardship along the way, which could be during college and is often going before that, and or you could be a first-generation US citizen or a first-generation college student in your family. If you come and join the Bridge program, you'll be fully funded in a sense similar to the sense of full funding that you heard about earlier and hearing about some other programs. You won't have to pay. You won't have to take out any loans. Rather, you would get stipends some of the time, and other parts of the time you'd be supporting yourself by teaching in the classroom as a GSI. The stats department also has opportunities to work as a graduate student research assistant in the Bridge program. You do some of that in the summer. And ordinarily it would be later in your career in the PhD program where you might also do that during the academic year. In all cases, tuition would be covered. And as I mentioned, you wouldn't have to take loans and that sort of thing to deal with tuition or health insurance. There's some travel funding that's available as well, particularly for students whose research projects bear that sort of fruit, that they could present it at a conference outside of Ann Arbor, which we fully expect many of our students to do. In terms of admissions, you've heard some things about admissions, and I expect that we'll be talking admissions more later. I'll just say a few comments specific to the Bridge program. It is possible to apply directly to our Bridge program, and we encourage you to do that if you've sized this up and find this perfectly applicable to you. Another route in which we wind up evaluating applications and bringing people into the Bridge program are students who have applied to our PhD program, but the PhD committee identifies them as being suitable for Bridge, perhaps for some of the reasons that I was indicating at the beginning. Very strong candidate overall, but maybe in some specific aspects of their portfolio suggest that they might be more strained than we would like to see in the first year cohort with other students that we're admitting who may have been stronger in that specific thing. We get applications from all over the United States, and they tend to have a variety of different kinds of backgrounds, including the ones mentioned in the bullet point here. The last thing I'll mention about the Bridge program is we created the Bridge program, we maintain the Bridge program, we run it, all with a view towards feeding our PhD program. However, that being said, if we admit you to the Bridge program and you accept, we see it as our commitment to help you in whatever your choices may be at the next step. So if you decide not to go towards the PhD, you will have the department and the university support in pursuing other career options. But our sincere hope is that you will wind up in our PhD program, and to facilitate that, we will offer fast track admissions to the PhD program for students who successfully complete their research project over the summer between their first and second years. We'll be looking very carefully at the products of that research and what role we can make for you in our PhD programs. And we'll be doing that evaluation even before we begin gearing up for our regular PhD admission season. So if students take full advantage of the opportunities they have between first and second years, they can skip essentially submitting PhD applications to ours and other programs, and instead have acceptance to our program in hand by the time they would ordinarily otherwise have been submitting those applications. So that's my take, what I have to say about the Bridge program. And I'll be happy to answer more questions as well.
Great, thank you, Ben. So we've had a couple questions come in for the stats department, and I'll send those, I'll ask you and whoever wants to answer. I think the first one probably go to G. Does the stats PhD program like to see math GRE subject test scores, even if they are not required?
Right. So, yeah. So the GRE math subject test is not required. You know, if you have a good score, that would not hurt you. But does that give you an advantage? It's not clear. I actually like what Stanford does. Stanford actually requires the GRE subject scores, but not restricted to math. You can submit, you know, any GRE subject score. So I feel, you know, I think, you know, having a good GRE math score is good, but not necessarily to be just a math.
Okay, thank you. Ben, this is a question about the Bridge program. Is it possible to complete the Bridge program and then go into the Biostatistics PhD program?
Oh, yeah, that would absolutely be possible. Like I said, we would view that as in much the same way we view students who complete our Bridge program and go to do something entirely different than a PhD, except it'd be better for us because you'd be right across campus.
Matt, we also have some slides to answer some of the pre-submitted questions. Do we still have time to do that, or?
Yeah, go ahead.
So I'll also share my screen.
Yep, I can take this down. And actually, while you're doing that, another question came in. What would make a student choose biostatistics over statistics or vice versa? And be gentle with your response.
So Ben, maybe can you take on that? I'll try to share my screen with the questions.
Yeah, nice job grabbing the screen sharing task right in the middle of that one. No, I think the basic answer is that in statistics, one of the basic differences to bear in mind is that in statistics, there are a number of the faculty who work on questions that would be very familiar to biostatisticians, as well as faculty who are working on rather different sorts of things, financial data, for example. So we're in that sense more diverse. I would not claim that we're more diverse in all respects, but in that specific sense, we are. I'd welcome other colleagues jumping in to add to that.
Yeah, I think it partly depends on where you are. I think Michigan is one example of where the statistics and biostatistics departments overlap very substantially, but as Ben points out, have other areas of interest application different than those we have. We do have a very strong biomedical focus, although there are some people who go through our program and end up doing something that would be very much akin to applied statistics. So I think the answer is a little bit more complicated. Our programs, I think, are close and similar. Other places, not as much. There might be more of a divide in terms of theory versus application.
Yeah, I just wanted to add that I think that it is our departments are, you know, very collegial. As you can see that we're hosting this together. So we are really not fighting for the students, but wanting to recruit you jointly. So we have a lot of joint effort. And if you are interested in more, there are committees for both biostatistics and statistics students, which actually have expertise from both departments. So I think the boundaries, the disciplinary boundaries are blurry at this point, but I think there is a very strong integration and collaboration between the two departments, and also co-mentored projects. So I think that has been growing. We also have a joint research retreat where faculty share ideas. So I think the departments really collaborate well. So that's my perspective.
Thanks, Mike and Burma. Maybe I'll just, me, Long, and Ben, we can together answer some of the pre-submitted questions from students. Can you see my screen?
Yes,
Yep.
Chi.
Okay, great, thanks. So the first question is, what is approximately the timeline for admissions to the PhD program in statistics? So our application deadline is December 15th, and we usually make the decision in mid or late February, and and your decision has to be made by April 15th. So that's the timeline. Hold on a second. Sorry. What are the prerequisites? I talked about this. And does the Mass GRE matter for most schools? Actually, again, I mentioned the Mass GRE is not required. I think for most PhD programs, it's not required either. Do we need to submit a separate applications for the master and the PhD programs, or is one application enough? So we used to have a like a procedure where you can submit to the PhD program, and there will be a checkbox indicating, if you are rejected by the PhD program, are you willing to consider for the master's program? So in that case, you can submit just one application to the PhD program and indicating that you are willing to be considered for the master's program if you are rejected by the PhD program.
And the same is true for us in biostatistics.
Mm-hmm. And does it matter if people outside of statistics write you letters of recommendation? I think, if it's a good letter, if it's a strong letter, it will not hurt you. But if that's the only strong letter, then that's not a good sign. I think, letters from outside statistics can give different perspectives about you, about your work ethics, about your characteristics. So that's good. But you should definitely have at least, a few letters from statistics. So this could be like an additional benefit, but this cannot be the only strong letter for you. What are grad schools looking for in prospective PhD candidates? How much research experience are you expecting to see in applications? It's hard to quantify the amount of research experience, but I personally feel that having research experience will definitely strengthen your application. That will help you get a strong in-depth letter of recommendation. That will also make your statement more relevant with more concrete material. So, for example, like the BDSI, this kind of summer research in summer schools can also offer you good opportunities for research experience. And also, as we, both Mike and I mentioned, the PhD program is about research ultimately. So I think you do want to demonstrate that you are committed and you have potential for research.
Yeah, G's answer would also be appropriate for biostatistics. It's great to have research. It's not required, but it's great to have.
Yeah, it's not required, but it's great to have. Yeah.
I would add briefly to that nowadays it's a little weird, a bit of a flag to read an application from someone who has no research experience whatsoever, because there are so many opportunities being offered to students. However, participation in the Big Data Summer Institute would very squarely satisfy that requirement. So you're good shape if you're here.
Yeah, I'd also like to add that, of course, if you have research experience, it's wonderful, right? Because that allows you to stand out. But many of the students don't necessarily have a lot of research experience. So the way you can help yourself, make yourself stand out is you have a clear sort of, you have a good collection of courses you take, and you have to be able to connect those courses to what you would like to do for grad school, so people can see how you plan, how can you prepare for, what is ahead.
Absolutely agree.
Great. Yeah. So the next question is, does taking time off between undergrad and grad school offer any advantage experiences that are useful in grad school? So maybe some of you want to jump in to take on this question.
I think either way can be great. If you have something you want to do, if you'd like some time off, just from the point of view of time off to recharge batteries, that's fine. If you're doing something that's actually going to be relevant in some way, that's even better. the little bit more maturity that time off can provide, I think can be valuable. That said, I'm delighted when people come right from undergraduate. This is one of those places where either choice is fine. If you do take time off, if there's something that's directly relevant to, or at least tangentially relevant to what you're going to do in graduate school, so much the better.
Yeah, I agree. Yeah, either way is fine. You know,
And I think the graduate students are going to give their perspective on that as well in a few minutes.
Yeah, that's a good point.
I should say one of the things that we are in the midst of working on in the statistics department is making sure that we can offer the best possible transition into PhD school for students who have been out for a year or two, as well as for the students who are coming directly from undergraduate, because we find that there are just so many different ways to make a very strong PhD program. There are absolutely some who've taken time elsewhere out of the academy and are much stronger for that reason, as well as some who are coming straight out of undergraduate and do well. And one of the ways that we are doing ongoing improvement is making sure everyone can relay that experience as smoothly as possible.
The statistics might be different from many other fields, that people come to statistics in different ways. Could be from different backgrounds, and you gain appreciation for the field by those kind of experience. And so, you know, sometimes you take a few years on, you know, working on some other fields, and you realize that you need statistics, you need data science, you need all these skills. That's why you go back to school and you can form the kind of question you want to study that nobody else maybe consider. So that's how somebody like Leo Bryman took years off and come back, and he invented, you know, decision tree and so on. You can also do that.
What about this one? How are grad school applications similar, different from undergrad applications?
Yes, I can say one thing about that I think is important to bear in mind, which is that an undergraduate application will be read by a professional reader of applications. A PhD school application will be read by a faculty member. So we just love to see when we're reading that, not so much that great experience you had and out of bound, whatever it may be. We love to see a student who has been moving forward along the challenge of writing about the sort of things that we have to write about and communicate, writing about those things in an engaging and clear way. We love, love, love to see that. Again, a nice anecdote can be nice, but we're not professional readers of applications. We're professional statisticians, and we're looking at you as a professional statistician as well.
Yeah, I also want to add that for grad school application, in terms of the selection criteria, it's maybe more focused on your undergraduate academic experience in comparison with the undergrad application.
For me, obviously it does matter all the things you've done, but I'm really interested in seeing what you want to do and why biostatistics or why statistics or why data science is exciting to you, fits with your life goals, your career goals, why you're passionate to go in that direction. And those are the statements that get me excited.
This is the second to the last one. What are the key things prospective students should consider in choosing which? Long, do you have anything? Because this is probably like talking about master's program versus PhD's program.
Master versus PhD, right? Sometimes your PhD is a big commitment. You know, are you willing to spend the next 5 years to study deeply certain kind of problems and having to write a groundbreaking thesis and so on? And most of the time, actually, you will spend hitting your head against the wall because you are stuck somewhere. Do you have that perseverance? Do you have that determination? So some people have that, already have that clearly in their mind, but many of us are not that clear, right? So master program can be a sort of middle ground opportunity for you to learn. Is statistics what you want to study? Is biostatistics what you want to study for a big part of your career? And so you get a chance to learn more advanced courses work and find out more about your ability, your technical ability, finding more about yourself. So these 2 years is a good buffer. for you to make, a decision too. People can be successful in either way.
I think they're both fantastic options. Statistics and biostatistics are wonderful fields with all sorts of opportunities. I personally love having a PhD because that's my badge that says I can do research and I can do whatever I want to do. And I can't say that that's true for all jobs you'll get with a PhD in biostatistics or statistics, but you tend to have more flexibility in deciding where you want to go and what you want to do. If we go to the extent of what about being a faculty member, that's one of the best things about being a faculty member, and that's something you can do potentially if you have a PhD that you wouldn't do with a master's.
Yeah, I also want to add this for the master program statistics is that some of the fields now, if you are interested in doing PhD, say in political science, right, or in mechanical engineering, some of these students, they actually enroll in the master program in statistics to learn more about statistical methods and machine learning and so on. And then they go on and apply for a PhD or a more advanced career in other disciplines. That's also a possibility.
One thing I would add is that if you think it's very likely that you're interested to pursue a PhD ultimately, you should certainly consider applying to PhD programs here and elsewhere for the simple reason that many programs will have the bulk of their student support resources devoted to the PhD program, so that you may be able to secure a more favorable funding package if you're also considering PhD programs. That being said, it's also the case that there are increasingly many students who start in a master's program and ultimately do complete a PhD. So you're not closing your door either way.
So the last pre-submitted question is keeping the COVID-19 situation in mind. What are the specific changes in the admission process this year? I think one thing I can mention is that we are thinking this year the GRE is probably going to be optional. It's not final determined yet, but I think most likely the GRE will be optional this year. I don't know about Biostat. Does Biostat have any?
Yeah, as I said in my presentation, I think it's very likely, and I think we'll decide next week. I think it's very likely the GRE will be either optional or not required. And the other thing we're going to actively do is to try to have more opportunities for meetings with faculty and students on a virtual basis, because our prospective student day, our admitted student day, which are our primary in-person recruiting events, honestly, I think are going to be virtual. And to do that, and then to add to that, that's another thing I believe we will be doing in the next year, trying to reach out, trying to do the best we can under unusual circumstances.
Right. The same in statistics. We already did in our previous admission cycle. We did our visit day online, and it's probably like we're going to do the same next year.
We had two questions come in that were very, very specific for the stat folks, and so I wanted to get those answered. Ben, what is the admissions timeline for the bridge program?
Oh, I think that's simple. It's similar to the PhD program, but with a bit more flexibility. At least if the schedule works out precisely the same way it did last year, which I'm not 100% certain of, but is likely. You'll have a couple more weeks to get in the application for bridge as compared to the PhD application, which is due a bit earlier. But nonetheless, we're likely to get decisions out at around the same time as our PhD decisions are getting out.
Okay. And then Long, for you, question on the Masters in Applied Statistics. Is funding only available to international students in the second year? And is funding merit-based or need-based?
For international students, yes, we typically we have funding for the second year, and for second year student, international student, we do have some are funding for domestic first year. You come in with a full package, but for the second year international student, it is merit based too. Typically, you look for someone who can be GSI for some of our classes, and we look for those who perform well in those courses.
Right. I want to just add, actually, even for international students, it's also possible for international master students, it's possible they get a GSI assignment in their first year. Usually, they go to students who went to a English spoken institute as an undergraduate. If they have done their undergraduate degree in a U.S. institution for 4 years, then it's possible they can also get a GSI assignment even in their first year. But also, of course, depends on how many GSI positions we have.
It depends on availability and all the other factions, small factions.
And the follow-up was, is that merit-based or need-based for the master's program?
It's mainly like a merit-based.
And then this is another question that came in. I think this is a really good question. And to hear both from the stat and biostat side, people talked about the importance of having some kind of internship or research on your application and how that really shows interest. So this person asks, how would you recommend approaching gaps or lack of experience in your resume because of canceled internships due to COVID? So for example, how BDSI was canceled this summer.
So yes, I can just comment on the BDSI part, because not just BDSI, all the SIBS programs, which is Summer Institute in Biostatistics, all the 7 SIBS programs were canceled. So it was recommended that, the students who were admitted, first of all, for the juniors, and I think this was the last opportunity before they graduated. So everybody who were admitted, we welcome them back to the SIBS. So we are holding their admission to the BDSI program. And that was the general NIH guideline. But in general, you can put in that you were admitted and offered BDSI, but canceled due to COVID-19. So that shows that, you were proactive and it was just the circumstances.
That's exactly what I would do for the biostatistics application. This is not a standard blemish, but it's something that was totally out of your control. You were trying, as Bramar said, to do something that would give you that experience. You weren't able to do it. There will be total understanding for that. This is a year when absolutely it will be understood and will not be held against you.
And I want to mention that similar for any presentations, or if you're supposed to go to an undergraduate conference, then your presentation was canceled, all of those events where which would have substantiated your CV in terms of outreach and presentation and internship, you can mark that COVID-19 canceled due to COVID-19.
Thanks, Pramar. Thanks, Mike. So I think we're going to move along now with our
sharing my screen.
Yep, we're going to move along now to the next part of the agenda. And so this was getting to hear from the current graduate students in each of the departments in biostatistics and statistics. And so we've given them your pre-submitted questions, and so that we'll have students addressing each of those, and then there'll be some time for some live question and answer too. But before we have the students answer your pre-submitted questions, we just have a video that was prepared by a current graduate student in statistics who couldn't actually join, but she wanted to give her message about her experience and what the path that she took to get to statistics. So this is Ajane Bennett from the statistics department.
Hi, my name is Ajane Bennett, and I am a current second-year master's student studying applied statistics at the University of Michigan. So I just thought I'd share a little bit about my experience entering the graduate program and my time here so far at the University of Michigan. So just a little bit about my background. I attended Amherst College and I studied mathematics there. And I graduated in 2016, so now about 4 years ago. And after studying I knew that I definitely wanted to pursue statistics, but I didn't know in what way. So I went into finance, and my role there was mostly risk management. I did spend a little bit of time in actuarial science and taking actuarial exams. And then I moved to the investment side of finance and was working mostly on commercial mortgages. And there I definitely had some exposure to statistics, using some financial modeling tools, but I definitely wanted to look into that more and really have a grasp of the underlying statistical models, and I felt like I needed a little bit more expertise in order to grasp that. In addition, I kind of had some experience with that in finance, but I didn't know if that was exactly what I wanted to do, so I thought school was the next step to kind of explore some more topics and to really try to get a sense of what it is that I wanted to do. So that kind of led me to pursuing graduate school and thinking more about what I wanted to study. And I always kind of thought about statistics, even in my undergrad career. So I knew that's something that I wanted to study. So of course you kind of begin applying to different schools and looking at different programs. So I applied to a bunch of programs, obviously including the University of Michigan. And I kind of just threw my application out there just to see what the results would be. And I was fortunately accepted to the University of Michigan. And one thing I will say that stood out about the University of Michigan was just their commitment and focus on students. So as soon as I got in, I received emails from faculty just welcoming me to the department, as well as providing me with opportunities to get funding actually for my master's, which I definitely was not expecting in the beginning. A lot of times you hear that there's not a lot of funding out there for master's programs. So to have that opportunity to receive an award that would allow me to study at the University of Michigan without that kind of financial burden and financial pressure would definitely set Michigan apart. So I kind of joined, and I was very excited about the program and just the possibility of learning. Again, I didn't really know exactly what I wanted to get out of the program quite yet, but I was just excited to take different classes and see kind of how statistics has transformed and see new data and how to explore that, get the tools to be able to do that. So during my time at the University of Michigan, my first year was, I received funding to attend. So my first year, I was able to kind of have that opportunity. And then my second year, my second semester, I should say, I had the opportunity to teach. And I think that's definitely one of the highlights so far of my graduate career, is that opportunity to be able to be in the classroom and kind of structure a classroom from start to finish. So you're working with students directly, you're providing them office hours, you're giving labs and you're giving lectures, and to have that ability really has transformed my experience. And I think that's one of the passions that I've found while studying that I may not have found just by working or without that opportunity of teaching. And moving forward, I'm still kind of open to kind of what I want to study, but I think also one thing that has been super helpful just to kind of get my research focuses, to kind of explore those research focuses, has been the opportunity to do research with professors. I've had the opportunity to work with two professors, Ben Hanston and Mark Fredrickson, on a research project exploring balance and covariance, as well as looking at randomization. So just having that opportunity to be able to work with professors, even as a master's student, and be able to develop those research skills if I do want to pursue a PhD or go into the industry. Having that background will prove super helpful. So overall, I just think the funding opportunities, the teaching opportunities has really set Michigan apart in my experience. And like I said, I'm not too sure where the future will take me, but kind of being equipped with that background will definitely set me apart in my next chapter.
All right, so I hope that worked well. I hope you were able to hear that. I felt like anytime I moved anything on my computer, the screen froze up. So I hope it worked all right. So that was a great description on where Ajane, how she made it into graduate school in statistics, and she had the description of how she wasn't a direct from undergraduate too. So I think that was kind of useful, and what her experience has been both teaching and research so far. So now I wanted to move to the submitted questions for students. And so we have just to make sure that everybody gets a chance to participate and talk, we've sort of assigned these questions out. And so what I'll do is I'll read off the question and then send it off to the graduate students that are here. And then for the graduate students, the first time that you answer a question, maybe you can just say sort of where you went to undergrad, what year you are in the program, just to sort of introduce yourself a little. So the first question that we have is, what are some questions you should ask yourself, or one should ask themselves to make sure they are suitable or prepared for graduate school? So Natasha, do you want to take the first shot at that one?
Yeah, hi, I'm Natasha. I did my undergrad in math at the University of Texas at Austin. I think that I was coming into a PhD program feeling a little bit less prepared than others. So one thing that I considered as I was visiting programs is how much it seemed like the program was willing to support all their students and see people through. And I thought that University of Michigan really stood out in that aspect. It seems like they're not trying to weed people out, which is actually an impression that I got from certain programs. And they had like a collaborative environment. But I think that ultimately grad school can be suitable for anyone as long as you're willing to put in the work and you're passionate about what you do.
Hey, Jonathan.
Hi, everyone. I'm Jonathan Boss. I'm going into my 5th year in the Biostatistics department, so 3rd year of PhD. And I was actually part of the inaugural BDSI cohort in 2015. So I think in terms of suitability, I think the big question you need to ask yourself is what your underlying motivation for pursuing graduate study is, especially because it's such a big time and financial investment. So I would kind of use your personal statement to kind of explore what your underlying motivations are. In terms of preparation, I think take as many proof-based math courses. That'll get you prepared for the theory part, and a lot of maybe taking some courses in computing have also been very useful as I've been working on my dissertation. And then just basic things like developing good study habits and time management skills, things like that.
Zoe?
Okay, hi, I'm Zoe. I am entering the 5th year of my PhD in the statistics department. I went to Washington University in St. Louis and did my undergrad degree in math. And I came straight to grad school after that. And so if you're in that boat, one of the things I think would be good to ask as you're kind of going through the application process is if you are ready to do 5-6 more years of school, and if you're burned out on school when you finish your undergraduate degree. Because especially the first couple years, particularly in our department, are very heavy on courses. And so if you can't like bear the thought of studying for another exam, then it might be a good idea to take some time off before going to graduate school. I think I would also echo what was said before. I found it really useful for myself to sit down and ask why I want to go to grad school. Why do I want a PhD in statistics? And when I was getting ready for this, I actually pulled out my journal that I had been keeping when I was applying to graduate schools and went back and read through the list that I had made. And so I think doing some self-reflection like that will help you determine if now is the right time to be doing in stats or biostats.
Okay, thank you. Zoe, I think you cut off there a little bit at the end. So the next question that came in was about taking time off between undergrad and graduate school. It's sort of got asked a little bit already, but advantages and disadvantages, or what experiences might be useful. And so I think Charlotte said she could address this. She took time off. And then if any of the other graduate students, feel free to jump in as well.
Yeah, so my name is Charlotte. I use she, her, and I am a rising 2nd year in this PhD statistics program. I also saw a Grinnell student out there. I'm from Iowa, so shout out to that. But yeah, so I took 2 years off. I went to Carleton College, studied mathematics and statistics there, and then I worked at an economic consulting firm after undergrad where I was doing data analysis and visualization and sort of writing reports sort of work. And so I found that I'm happy that I took that time. When I was deciding about going to grad school, I asked a lot of people this question, and people wouldn't really give me a straight answer about whether or not they thought it's better to take off time or not. So I do think it's really personal. But the advantages that I've found in my first year of the PhD program have been that I have much better communication skills than I did straight out of undergrad. And in general, academia doesn't necessarily provide clear expectations or clear professional training for students, but I did get that working. So I, had a mentor, and I had very clear expectations about communication and working with managers. And that's helpful to then bring into this setting that's a little bit less clear. I also feel like I can connect now with my research a range of different applications that I was exposed to in a job that I hadn't had in undergrad. And I think that, as people have alluded to, the first year of grad school is very challenging, and it takes some emotional fortitude to get through. So just having a little bit more emotional maturity is helpful. I know Dan wanted to speak to this too.
Yeah, so I'm Dan Kessler. I'm entering my fourth year in the statistics PhD program. So I actually completed my undergraduate degree at the University of Michigan back in 2009, and I studied cognitive neuroscience. And then for about a decade, I worked as a researcher in cognitive neuroscience, as a software engineer and sort of as a research analyst. And so my path to statistics came through the work that I did in between. And there are certainly, especially I think in the first few years, disadvantages that can come with taking especially a substantial gap like I did, where a lot of the skills that you might have built, especially studying math or statistics as an undergraduate, will atrophy and rust. And so depending on what you do in your gap, it's unlikely that you're doing real analysis proofs or using linear algebra extensively in the way that you might in your first year coursework. And so I think you need to be prepared to be a little patient with yourself. But I think there are a lot of advantages of taking time off. And I think that there are a lot of emotionally challenging things about being a graduate student, and having a little bit more perspective and experience that you get from taking time off can be really, really useful. Sort of expanding on what Charlotte said, a lot of my experience with PhD study is that things are often fairly unstructured, and there's a much greater onus on you to build your own structure, both in the way that there are a lot of resources, but you really have to advocate for yourself and have an idea of the type of relationship that you want to have with your advisor, the approach you want to take to your coursework. And so just having more experience and having spent more time working in different organizational systems gives you a little bit more perspective to come into graduate study and to not just view it as sort of a continuation of what you're doing as an undergraduate. So I think that experience and sort of that emotional maturity can be really, really useful for perspective.
Thanks, Dan. Thanks, Charlotte. So the next question that got sent in was, how does grad school differ from undergrad? New challenges or obstacles? And a couple of people asked about how are the interactions between fellow students and faculty different? So Abe, you want to take the first shot at that one?
Yeah, hi everyone. My name is Abe. I'm fifth year in the Biostats program, so third year PhD. Similar to John, I was in the inaugural 2015 Summer Institute program. And so I went to undergrad at the University of Michigan, graduated 2016. And so of course, Michigan is a pretty big school. So I would often go into these huge classes, knowing maybe one or two other people, but in grad school, that's completely different. Pretty much all classes are with most of your cohort, so you know everyone else in the class pretty much, and it's a lot easier to discuss homeworks and going to office hours together, getting questions answered. And that's extremely helpful because a lot of the homework assignments are you'll find they're pretty hard to do on your own, so that's definitely one advantage. And similarly, with the smaller classes, at least for me being from a big undergrad program, you can get to know the faculty members a lot better, of course, going to office hours. And generally speaking, my experience at Michigan has been that the faculty also tries to make an effort to get to know the students. And so it's more kind of an adult interaction because you're a grad student. So the expectations are that in undergrad, maybe some people don't take the classes that seriously, whereas in grad school, I think the faculty knows all the students generally are taking the classes seriously. As far as new challenges or obstacles, I think kind of what Dan was saying, a lot of it is self-motivated. Like I think in undergrad, a lot of times you're just going through the motions in classes, doing what you can to get each assignment done and knowing what you need to know for the exams. Whereas in grad school, the material you're learning is what you're going to use for further research and throughout the rest of your career. And also in terms of your own research, like the research you do, although of course you'll have an advisor with general expectations, I think a lot of that is on yourself to really see what you can do, how to go about tackling certain problems. So in that sense, grad school requires a little more this self-motivation and self-learning than undergrad.
Yeah, I think it was a great answer. And I would agree that one of the biggest differences is the degree to which you are self-accountable. And there are like some advisors who will help hold their students accountable as they're making progress on research. But for the most part, being self-motivated and self-accountable is much more important in grad school than it is in undergrad. And I'd echo specifically one of the perspectives I had coming from a working environment that to me was somewhat surprising, seeing other first-year students when I was starting in the program, is just how much more radically flat the hierarchy is, especially in my experience in the statistics PhD program, where as an undergraduate, there's a very large power dynamic that exists between like senior faculty and undergraduates. And although academia still has some hierarchy, at least in my experience, like the statistics program, essentially everyone's on a first name basis. And I remember seeing it took, especially people coming directly out of undergrad programs, it took them a little while to get used to this. I mean, people would come to me because they'd want to write an email to a professor and they'd want me to read it first because they were really worried if they were being offensive or if they were being too forward. And so I think it takes a little while to build confidence if you haven't been having more of these sort of like adult interactions to get comfortable with that style of interaction.
Yeah, I agree with all of what's been said, and I'll try to keep this short. But a couple of things I wanted to add is one difference also in terms of student-to-student interactions is that fellow students are now both your peers and your colleagues. So that can, I don't have super specific examples for how that changes things, but it does change the dynamic a little bit. And also, I found that I had to completely change my strategy as a learner and as a student, which has been sort of alluded to, partially because I happened to, in my undergrad, not experience this, but in grad school, I experienced being in classes where I really didn't have the prerequisites. Like there was expected linear algebra knowledge that I just didn't have. So that changes how you need to study and approach the classes. And as we alluded to before, just doing more group learning is helpful. And finally, to offer the perspective, I went to a small liberal arts college. The incentives and priorities for faculty in an R1 institution are different from that at a liberal arts college. So that's just something to keep in mind. So the culture or environment in a department in our R1 institution is going to be different from a liberal arts college. And that's not good or bad, just something that's different.
Thanks, Charlotte. We're going to loop back to question number 2 again. So Ed Wu is a graduate student in the staff department, and he had an additional comment he wanted to make on the issue of time off between undergrad and graduate.
Hey, can you guys hear me?
Yep.
All right, just making sure that my headphones are working. Yeah, my name's Ed. I am a 4th year PhD student in the stats department and are about to be a 4th year, and then I'll be entering my 6th year overall in grad school. I did 2 years in the master's program before entering the PhD program. And I guess my background is somewhat similar to Charlotte's. I studied stats as an undergrad at Columbia, and then I worked in economic consulting for 3 years before coming to grad school. And so the first thing I just wanted to point out is that it's not always clear if you even want to go to grad school, and taking some time off to work before entering grad school, before applying for grad school, can really tell you if the grad school life is for you, or rather if you think the grad school life might be for you. You could work for a few years and instead think like, why should I go back? And that's perfectly fine too. Or you might work for a few years and realize you really don't like what you're doing, and that grad school is a path to a different career. So that's one thing. The other thing is that you might not be ready to be a graduate student. And this kind of ties into the current question: how does grad school differ from undergrad? If you were like me, I was not exactly the most diligent undergrad. And if I had gone straight into grad school, I probably would not have succeeded. My time management skills weren't very good. I wasn't particularly self-motivated. But spending a little bit more time working, I think really helped give me that motivation. On the other hand, if I've met plenty of my peers that went straight through from undergrad. They had no problems transitioning from undergrad to grad school. They already had the right mindset. So it really varies from person to person. And the last thing here is that like, depending on your job, you may pick up different kinds of knowledge that can be helpful for graduate school. You might not necessarily be learning more about theoretical statistics or math or anything like that, but at the same time, you can get better at time management, at communication, at like the technical coding skills that can be very helpful in a stats PhD. So it definitely can help in other ways, even if you're not getting the classroom knowledge that's going to help you in a stats PhD. And then the last thing, connecting this to the difference between grad school and undergrad, especially in a PhD, grad school can more often be like a job, right? And that's sort of up to you because there's a lot of flexibility in your schedule, but you can make it more like a job. And so if you have more experience working a full-time job, it can really help you structure how you go about your daily life. Yeah, sorry, this is a bit of a ramble, but
no, you're good, Ed. Thank you.
If you have any questions, I'll be happy to answer later.
Good, thank you, Ed. So getting back to question number 4 here, how did you research what field you wanted to pursue before applying to grad school? So Corey, do you want to start with that? And also, please, as a reminder, just introduce yourself too, right?
Yeah, sure. So I'm Corey. I'm a rising first year at Harvard, pursuing a PhD in biostatistics. I did BDSI last summer, and I just graduated from Case Western Reserve University with a bachelor's in statistics. So how I decided, I was basically debating between epidemiology or biostatistics because I knew I wanted to do something that was more application focused and more medically focused. And then I decided by talking to a lot of different faculty, like Bramar was really helpful, talking with her about it and talking with current PhD students. And basically what I realized is that I wanted to be able to both develop methodologies and apply them. And I felt like just doing a PhD in epidemiology might give me a bit of a ceiling with not necessarily having a theoretical background. So I decided to pick biostatistics because it's more middle of the road where you get the application focus and the theoretical focus also.
Awesome. I'm Natasha. I think I forgot to mention that I'm a rising second year and I'm in the statistics PhD program. And I knew I was interested in math and computer science, so my experience is a bit different in that aspect, but I think what really helped me decide to apply to grad school was interaction with current grad students in math. my TAs and courses, as well as participating in a directed reading program where I was paired with a grad student to read papers in the field, as well as an RU that I did, sort of like the BDSI, where you got to do research during the summer. So I think those were the experiences that really convinced me to pursue graduate school.
Hi, my name is Eric. I went to undergrad at UC Santa Cruz, and I majored in math and econ. And I'm a second-year master's student in applied statistics. I think what made me want to pursue applied stats was that I just looked at like previous coursework that I really liked, and one course that I really liked was econometrics. So it felt like a natural path to kind of pursue a applied stats master's degree.
Hi, everyone. So I think for me, I knew for a while that I wanted to do statistics, like even before I entered undergrad. So I think this question for me was more of a battle about what subfield within statistics, because as has been noted numerous times, statistics is such an interdisciplinary discipline that you can pretty much work on problems in any other field that you want. And so what I would recommend is maybe thinking about what other topics you like besides math and statistics, maybe computer science, and maybe looking at how statistics is applied to that particular field and see if that at all interests you. And that's ultimately how I wound up in a biostatistics department, because I find questions about environmental health particularly interesting.
Thanks, Jonathan. And I would echo, I really like your piece of advice there on finding another field that you like and finding ways to use math or statistics in it. So I was a math major myself in undergrad, wound up taking a genetics class, and that is really what turned me on to showing up in biostatistics, is finding another field that I really like. So I think that's a great piece of advice. So the next question is, this is a very common question that people who apply to biostatistics program ask: are people coming with a bio background or a statistics background? And so here I'll let each of the biostat students sort of take turns to say a little bit about your background and then your experience with the other graduate students that are in biostat. You know, if you have examples of people who maybe come from fields that really are not represented here, but you know, I think there are students that show up in biostat that do all sorts of things beforehand. Jonathan, why don't you go first?
All right, yeah. So I came from, so I did my undergrad at Michigan State, and I did my undergrad in both math and stats. So I came from a pretty heavy theoretical math background. And I think the majority of the biostat students do come from like a statistics background. Although there are members in every cohort who come from like biochemistry, biological sciences, maybe wanted to attend medical school but changed their mind. There's definitely a healthy chunk of each cohort that comes from that background. Yeah, I can speak more to that, but I mean, I can't really talk about what it's like to come from a biology background. So.
Abe, you want to? Yep.
Yeah, sure. Yeah, so I started undergrad thinking I wanted to do medicine and took all this orgo, biochem classes and didn't like them so much. So then yeah, about halfway through is when I switched to stats. And yeah, I mean, I think having that combination helps in terms of your research. It might not help as much with like the statistical theory classes. I think it helps with whatever type of research field you go into. Like I'm doing statistical genetics, and having that background in genetics from undergrad definitely has helped in knowing at least some of the basics. And yeah, like John was saying, I know a lot of people from our program come from purely bio or genetics backgrounds and just took the prerequisites to come to the program. And I think for sure there's a bit of a difference maybe in the first like month or two in terms of getting up to speed if you don't have as much of that stats or math background. But then I think after that it becomes pretty even. So it's definitely people come from both of those similar backgrounds, and I think that it works out fine for anyone.
Thanks, Abe. Does anybody from the stat department want to chime in on people showing up with a background that's other than the usual math or stat background?
So I'm one such person. So it certainly happens in statistics. I don't think it is exceptionally common, but I think G alluded to this. And I think this is also one of the things that if eligible, the bridge program is potentially a really good fit for, is that I think in many cases when people come from outside of statistics or math, there's more frequently gaps in prerequisites. So like I spent more of my first year filling in some of those gaps. And that is a more challenging road to row, I think. But if you decide that you want to do it, it's, at least in my experience, it was a very worthwhile challenge.
Thanks, Dan. So the next question was, what are some things that you wish you knew before applying and or attending graduate school? Any suggestions on preparation? So Jonathan, I have you up first for this one.
So I answered the preparation part for the first one, so I'll just focus on the first question. I don't know if there was a question that I was, or something that I was completely unaware of, but there were definitely things that I didn't maybe internalize or like fully comprehend. I think one of the biggest challenges in graduate school is when you maybe go to a conference and you see a talk and it's this really cool idea, and you know, when you see a presentation, you're seeing the final product of the work, and you're not really seeing the struggle that went into getting to that final product. And I think that's a really important lesson to learn for graduate students that are early in their career, to remember that, you know, people didn't just sit down and figure this out, you know, instantaneously. These things take time, and you need to be, when you're pursuing a research degree, you need to be patient and resilient with things. And so that's one lesson that I think I kind of knew, but I didn't really comprehend until, I guess, maybe a more later date in my PhD. So.
Thanks, Jonathan. Actually, I would say if you were reviewing all the graduate student faces when you said that, there were lots of head nods. So I think that's a common experience. Charlotte, did you want to add on to that?
Yeah, one thing I want to mention is I had outdated information about whether or not it could be useful to get a master's in statistics. So making sure that you actually talk to people about PhD versus master's is one thing I wanted to mention. I also think, similar to Zoe talking about like actually writing things down, sort of journaling, I wish that I had thought harder about the kind of learning environment and department culture that I needed to be successful and to feel supported, and like had actually written that down, just so that would have helped me, I think, ask the correct questions when visiting graduate programs. I also wish I had found someone who would have been really, really honest about what their first year was like. In really specifically, I think a math or a statistics graduate program. Some of my friends from PhD programs came out later during this year to explain to me how it had been for them. But I think that's a really helpful way to prepare, just to set your expectations and get their opinions on it as people who know you as well. And just in terms of before applying, I think about if you do have any career goals, how they might align with places that you're applying. So if you want to be in academia, that is going to be a different kind of application pool potentially than if you don't care about that, and maybe you're willing to, or you want to look at schools that aren't as highly rated to get the department culture that you want. So I think that those weren't things that I had in mind that people hadn't talked to me about that I wanted to bring up.
Thanks, Charlotte. Eric?
Yeah, so in terms of attending grad school, like for preparation, some of the courses are, at least for the master's program, they are kind of taught as like you should know this, like in terms of math. So I would like suggest maybe if you're like a little bit rusty or took a few years off, like before attending graduate school, maybe like reviewing like fundamentals like on your own before attending, maybe a couple weeks before. That'd be like really helpful.
Thanks, Eric. So question number 7 here. What are some important things to consider about the graduate school you choose to attend? So we have Abe.
Yeah, so I think one important thing to remember is it's going to be a pretty long portion of your life, especially if you're doing a PhD. It's going to be like 5 to 6 years you're going to spend at this place. So you have to make sure, in addition to advancing your career, you're going to actually be happy there. So I think going to a place where you like the area, you like the feel of the whole town, maybe if you really want to live in a big city or something, or a small town, to consider something like that. And also, of course, the atmosphere of the department. Like, I think for me, I like to have a more laid back atmosphere, not really competitive. And so just kind of having classmates, so you're going to meet like graduate students when you explore what department you want to attend, and you can mostly tell, I think, how the atmosphere is, whether people are feeling more competitive or it's a more cooperative environment and people are friendly with each other, faculty seem friendly. And so for me, that actually was pretty important to why I chose Michigan, because I got that feel from the department here. The faculty want the students to succeed, and the interactions are more casual between students and faculty. So I think, yeah, just general life, how it's a life decision is an important thing to consider.
Thanks, Abe. I would concur with that idea of picking somewhere where you actually like the area and there's things around there for you to do. You do spend more time, especially if you're going for a PhD, you spend more time in graduate school than when you do in undergrad. Okay, Charlotte, you want to add something?
Yeah, I would just add making sure that, like, just paying attention to who the faculty are and what they're working on, and seeing if there's a broad range of focuses or that department seems to have sort of specific focuses, and whether or not there's at least a handful. You need to have at least a handful of people who look like they'd be people you would be happy and excited to work with.
Zoe?
Okay, now you can hear me. Yeah, I would definitely agree with what Charlotte just said. If you have any sort of idea of the type of research that you want to do, then it's a good idea to figure out who in the department is doing that type of work. Because it's going to be less fun if you choose a program and find that there's no one doing the specific thing that you want to work on. I think also more practically, sort of things to ask current students about would be like how your stipend compares to your cost of living. How difficult is it to find affordable housing in the town or the city that the school is in? How is your health insurance? Things like that aren't maybe not the first things that come to mind when you're thinking about sort of fit with a department, but they are important and will also give you a sense of how graduate students are treated in that department or in that school.
Thanks, Zoe. Jonathan?
Building off of Charlotte's point, I think it's important, if you come in and you don't know what you're doing, you might want to choose a department that has a bunch of different options. You might not want to choose a department that's very specialized and you're kind of pigeonholed into working in a particular area by virtue of being a student at that department. So I think if you don't know what you want to do, it might be good to look at departments with a broad range of problems so that you can kind of think about that. The other thing I'll mention is that especially when you're doing a PhD, as people mentioned, it's usually 5 or 6 years, your relationship with your advisor really can make or break your experience. And so you want to make sure you choose an advisor that you get along with. And so I think that's a little bit more difficult to assess, when you're applying to graduate school, but make sure you try to have interactions with faculty when you're visiting schools and see if, you feel some type of, I guess, personal connection or something like that with them, because you're going to be working with those people for quite a while.
Dan?
One thing that I noticed that I didn't really think to investigate, but that seemed to vary a fair deal between statistics and biostatistics programs I was considering, was the amount of support for students, specifically in terms of resources for travel, for computing, for personal computing, for scientific computing. And I think that's something that a lot of, especially people coming out of undergrad, don't think to directly ask. But there are places where the norm is that students typically attend 1 to 3 conferences a year, and the department supports that. There are places where students are still able to attend, but it's really contingent on them like scraping together money from a variety of sources. That's certainly not like the most important thing to consider, but that's a question that seems to get asked very, very little. And especially if you're down to like 2 or 3 programs that you're really torn between, asking where you're going to be best supported, both in terms of your stipend, but if you need to travel to support your research, if you need to do a lot of computing, what places is it going to be easy for you to get those resources versus where you're going to have to kind of fight for them?
Good advice, Dan. All right, so for the last question, we're just going to try to get through everyone real quick. So quickly, just, I think a lot of students wonder, how many graduate programs you apply to, if it's maybe similar to undergrad where you send out a lot of applications. So, if you can remember how many you applied to, and then quickly why you chose to attend Michigan, or in Corey's case, some school out there in the East. I can't quite remember the name of it. So Corey, why don't we start with you on that one?
Okay, sure. So I applied to 11 different programs, 9 biostatistics and 2 epidemiology. I have some friends who applied to as few as like 7, and some who applied to like 20. So I would definitely say when you're deciding which programs to apply to, make sure you're not applying to any like safety schools where you don't want to go there, but you think it'll be easier to get in because maybe it's not as highly ranked or something. I mean, with graduate school, it's all about fit. And so maybe like you'll get into a school that's much more highly ranked and not get into a school that's much lower on the list, because it's all about fit and what kind of research the department's doing and whether the faculty think you'll be a good fit for their department. And that being said, like also look into how the program's funded. So example, at Harvard, so there's like genomics training grant, HIV, cancer, environmental statistics, like the funding pretty much comes through NIH training grants, and they're like specific areas of focus. So if you don't really have a specific area of focus, then you may be a really good applicant, but not necessarily get in because you don't like line up with how the funding works. So that's another really important thing to understand. And then in terms of why I decided to go to Harvard, well, it is the #1 biostatistics program. And then also there's just so much research going on in the Boston area, and so much interesting research going on at Harvard. And there were a lot of different labs that I felt like I would like to work with. And they also do rotations, so you can try out working with different PIs. So you really get a good feel with like who will be a good advisor for you. Because something that I've heard from a lot of current PhD students is that like a person may be the most like brilliant person ever and coming out with papers in Nature like every single year. But what really matters is whether they have an advising style that matches up with how you learn and how you work. So I think rotations are a good thing to look into. And then also just like having a lot of different labs that you can see yourself working with, and also the support that the program offers. So Harvard's very like proactive with like making sure students are supported, making sure that there's lots of conversations about like keeping like the mental health of the graduate students, like keeping graduate students supported and addressing those different concerns, because it's a long program, it's a hard program, and you want to find a program that'll support you and that'll help you through those times.
Thanks, Corin. So we kind of have to go rapid fire. We're a little bit over. So Natasha, why don't you go next?
Sure. So I applied to 13 and I visited 5 different programs. And I think for me, the visit days really helped inform my decision. So I would just encourage everyone to try to go to like as many of those as you can.
Dan.
So I applied to 3 statistics and 3 biostatistics programs. I applied to many other programs in other disciplines. But for me, the largest factor was I had a pre-existing relationship with the professor that is now my advisor. We had some existing research collaboration. I knew that we fit in terms of research interests and that we worked together really well. And in retrospect, that was absolutely the right thing to prioritize in making a decision.
Charlotte.
Yeah, I applied to 2 biostats and 6 stats programs. And I chose Michigan because it felt like it was a very forward-looking program and they were making changes, and that students had a large input in the decisions that the department was making and how it was changing moving forward.
Jonathan.
Yeah, so I applied to 6 programs, and I think the ultimate deciding factor for me was getting funding through a GSRA, coming in as a master's student and getting to work with Bramar.
Abe.
I applied to, I think, 11 biostats programs, and what made me choose Michigan was the BDSI program, where we got to know the faculty at Michigan, and I really enjoyed my experience with them. And you don't really get that chance at other places, so you never know. And then also for the visit days, I just enjoyed my time in Michigan. And being in Ann Arbor, I like the city, so I thought I might as well stay here a few more years.
Eric.
I applied to 5 stats programs and 1 econ program. And I decided U of M because of the funding and being able to be a GSI as a master's student.
Zoe?
I applied to 13 programs, all PhD programs in statistics. I would very much second what Natasha said about visit days being really important. And I think the community that I found here, both current students and other prospective students within the statistics department at Michigan, was the most important thing. I will also say and note that a lot of people feel drawn to necessarily go to the most prestigious school that they get into. I definitely felt that pressure, but I would strongly encourage you to look beyond the ranking when you're actually deciding where to go.
Thanks, Zoe. Ed, are you still available?
So I applied to about 10 schools. I actually did the application process twice. The second time I did it as a master's student, and I applied to 2 biostats programs, and the rest were stats PhDs. And I ended up coming here because I was already working with a professor in the stats department who I got along with very well and knew a lot of the students and had good relationships with them.
Thanks, Ed. So at this point, we were going to do some live Q&A. I'm wondering if Bramar, if you're around, do you want to do your closing remarks, Bramar? Because we are running a little bit over, and then if people want to hang around a little bit to do some live question and answer. I haven't seen many questions come in recently.
Yeah, so I would like to just, I don't think that I am qualified to do any kind of concluding remarks, but I'm just going to share my screen. I want to take a moment to thank everyone who participated today, particularly the graduate students, the faculty, my colleagues from the statistics department. And so I just want to show, and we talked a lot about goals and metrics and so on. So I'd just like to take a moment to depart. Can you see my screen?
Yep, we can see it.
Okay. And so I'd just like to take a moment to depart from the metrics, because we have talked so much about metrics, how many applications, how many, what is the funding, what are the criteria for GPA. So I feel like one downside for me for academia has been this metrics and this metrizable space. And so I think we often talk about just goals. I would really like us to think a little bit, as we're thinking about graduate school, a little bit about values. The values that in Michigan that we have discussed in our department is of bold exploration, purposeful inclusion, greater good, collaborative spirit, self-determination, and well-being. And if we sort of ascend to these values, the rest of our curve and also our progress and our destiny becomes clearer. And for the department perspective, I think that there are resources in the biostatistics department sort of to be consistent with our values. We really want to provide support for the translation of our work. So I wanted to thank Dan Barker, who has also set up this webinar, and you probably have received messages for him. He's our systems administrator. He knows a lot about distributed computing, how to use the Linux cluster, and has done an amazing job with the biostatistics computing system. And Mike Kleinsesser, whose assigned job role in the department is actually take the products, take the wonderful mathematical methodology that we create and translate that to our packages. And I think in today's day and time, if you do not have a package, then the impact of your work is actually very limited, and the current students are going to ascend to that. But in order to support the students to do that last mile, to take your code and take them down from GitHub and actually make a formal R package submission, so the department is actually providing that support to all students and faculty. And then also, I think the well-being part of graduate school is often very undermined, because we are just, again, focusing on the metrics that we need to achieve. To that end, the department for the last 2 years has an in-house student navigator with a degree in social work, and Andrea Hill has been an asset to our department. So I know that many of you are figuring out life and thinking about the uncertainties that are surrounding your graduate school application. It's a disappointment that your internships and summer programs have been canceled. But I'd like to say, at the same time, in March, when the COVID pandemic actually was emerging as the generational defining crisis of our time, scientists also discovered comet Neowise. And this is a picture taken 2 days ago on the Stonehenge of comet Neowise. So I'd like to really, for us, as Matt said in the beginning, to focus on the positive things and the long-term goals that are there for in our horizon, and think about our values. And for Michigan, I think that Michigan is a very fun and collegial place. And we also, in the department, we have a departmental anthem, and this is the first 2 lines, which makes us think about the community values of Michigan. We are very brilliant statisticians. We want to provide the intellectual sustenance, but also want to provide something which is beyond the immediate. And so I want to thank every one of you for being here today. And I want to say, go blue. And again, I want you all to stay safe, stay well, and I hope that our paths will intersect at some point of time. So thank you for this opportunity for the concluding remarks, Matt. And thanks, Matt, for being a wonderful MC, and everybody who put this event together.
Thank you, Bramar. So that'll be the end of our program, but I think we'll stick around. Totally understand if people have to leave. We haven't gotten any questions in recently, but we'll wait a minute if, oh, here comes a question. So we'll answer a couple questions. So feel free to send them in. So how many I think this is directed towards graduate students. How many graduate students came into the PhD program knowing their specific subfields? When do people usually know? So I think this is, when do you know what you're going to work on? I think they're asking in your dissertation.
I can try to address that
yeah, go ahead.
question, and maybe some students can jump in later. So when you submit your application, you don't have to specify your subfield, and you don't have to specify whom you will work with. It's good, like, because if you know, like, who, what's your research interest, and you have specific faculty in mind that you want to work with, you can say them, you can write them in the statement, but it's not required. And most of our students, they start to explore research opportunities in the first summer, like after their first year. And most of our first year students will work with one or maybe more than one faculty members in the after the first year, in the summer after the first year. But even like that, faculty members you work with in your first summer is not like a fully determined. You can change your advisors later. That's also possible. So overall, like, most students, they will try to decide whom to work with and their subfield in their second year. And the students can jump in if they want to share their experience.
If any students want to say sort of when you figured out quite what you were going to work on.
I can talk to that. I came into the program basically knowing nothing about what I wanted to do, except knowing that I wanted to do something that was a bit more applied. And I more went the route of, I found an advisor that I wanted to work with, and then sort of worked on things that he was working on. I knew it was really important to me to find an advisor that I would fit really well with. And so I kind of did that first, started working with him the end of my first year, and then kind of just continued down that path. But yeah, I didn't know what I wanted to do when I came in.
Thanks, Zoe. I think that's a pretty typical scenario, I think, for all of us. And I think one of the things you said is you sort of got a project almost initially, right? So that just to get you started. And I think the longer you stay in the program, the more you get to take shape of the project yourself, right? And I think that's by the end of your PhD, by the end of your dissertation, you know, that's where really you are making the contribution, and you know, your advisor is almost like a collaborator at that point. So I think that's the model. That's what you should be hoping to do. Does anybody else want to answer that? That might be the last question we have here. So one other question that came in is the Introductory Probability Theory series Measure Theoretic. Is a strong math foundation more important than applied statistics for the statistics PhD? Does a stat person want to jump in on that one?
Any student wants to take on that, or I can do it?
I can speak really quickly to it as someone who had more applied statistics work versus math preparation. So for the intro probability classes, I took the master's level classes. And so yes, for the coursework, a math foundation is more important than applied work, but there's still courses, so you can do it. There's lots of support. You'll get, like, I got through it and learned a ton in the first year. So while it might be true that a strong math foundation is more important for like the coursework in the first year, that doesn't mean that having applied statistical work experience isn't going to then help you later on.
I will also add to that, I 100% agree with everything that Charlotte said. I will also add that you can avoid taking measure theoretic probability. So if you take the master's level probability theory courses your first year, you do have the option to avoid the measure theoretic probability course. And I actually, this is a little embarrassing, but one of the reasons why I chose Michigan is that I had the option to skip that because I was terrified of taking it. And then I ended up actually taking it my second year and was really glad that I did. But you do have the option to skip that if you are planning to go more of the applied route.
Thanks, Zoe. So I think that's the last question that came in. So I think we're gonna end the session there. So thank you to all the participants who got to talk about their departments and their experience in graduate school. And I hope this was informative for the people who signed in to learn about graduate school, to learn about University of Michigan, departments of statistics and biostatistics. We are very sorry that we did not get to see you this summer for BDSI. Hopefully in the future, and if not for BDSI, potentially for graduate school. So thank you and good luck.